Okay, today's notes are on proportions, specifically looking at similar figures and scale factors. And we'll also look a little bit more at percents. If you know the sale price, how can you determine the original price? Again, we have a benchmark coming up on Friday, and the skills that'll be tested here are the ones that are on this sheet that you all have. The check-marked ones are ones we've already done. You can see a couple that we did just yesterday, and then the ones that we have yet to do today. The assignment that was due for today, the answers are right here. You can check them over, pause the video if you need to. And let's start with similar figures. So the idea here is that if I have similar figures, when I take this figure and I stretch it out, I'm going to take this one for a moment and just pull it, that I get a similar figure. All I'm doing is making it 2 times larger or 3 times larger. It's like if you stick something on a copy machine, that it's going to make it 2 times or 3 times or 4 times larger, or you can make it smaller. But the relationship or the shape itself is staying the same. In geometry, you specifically talk about the criteria being that all of the angles are still the same that they were in the old figure. So given that we have this relationship of similar figures where each of the angles are going to be preserved and the sides are just going to be a multiple of each other, we can come up with a scale factor. And a scale factor tells you that for each unit on this figure, it's worth how many on this one. So over here it says for every 1 inch or centimeter or foot, whatever your units are on figure A, that's going to be 3 times larger on figure B. So if I know that this side right here is 1.5, I know that to come over to this figure, I'm going to need to multiply by 3. Or I could actually set up a proportion. The side of A compared to the side of B is going to be a 1:3 ratio. So anytime I take a side on A, 1.5, and compare it to its matching side on figure B, which in this case is labeled D, I can solve this proportion to figure out the value of D. So I'm going to take 3 times 1.5, doing this cross product idea. 3 times 1.5 is 4.5, and multiplying the other way, I get 1D. So D is 4.5. And notice that is 3 times 1.5. Now I can keep doing this around using either the concept that each side here is going to be 1/3 of the sides over here, or by setting up that ratio 1:3 and writing a proportion. So B over 9. And so in this case, I'm going to end up seeing that just multiplying by 3 gets me there. So multiplying this by 3 would get me the value here of 3. And so this side would be 3 units long. And you can see again, taking the side times 3 gets me that one. Now notice I run into a small dilemma here when I get to this side, because I don't know the value on either triangle A or on triangle B. And so I cannot figure out what they are. So that's where I need to then take some more information and see that because these figures are also similar, that I can come up with my ratio of sides here because I know this longest side in both figures. So the ratio from B to C is going to be 9:18, and we always simplify the ratio. In this case, we get 1:2. So I can come down here and say this ratio from figure B to figure C is a 1:2 ratio. And then using that ratio, I can come up with the rest of my sides. So notice here, I can figure out that C over 12 has to be a 1:2 ratio. So C is going to be 6. And now that I know that C is 6, now I can come back here and figure out that A has to be 2. And I can come down here and know that each figure here, again, remember each side here is 2 times bigger than the side in this triangle. So 4.5 doubled makes 9. Now, another way you can look at this is you can actually look at the ratio of the 3 sides in the triangle. So if we call these 3 sides x, y, z, in the first triangle, x, y, z, I have a ratio of 1.5 to 2 to 3. This is taking X to Y to Z. And when I look at it in figure B, so this was in figure A, in figure B, the same matching sides is 4.5 to 6 to 9. That's in triangle B. And in the third triangle, C, I've got 9 to 12 to 18. This is figure C. So you can see that to get from A to B, every one of these sides was multiplied by 3 to get me these sides. And to get from B to C, every one of these sides was multiplied by 2 to get these sides. And within any triangle, I can see this ratio here, which typically we'll simplify it down as much as we can. Every of these numbers here is divisible by 3. So we call it a 3 to 4 to 6 ratio of sides. And that's when we want to look at and compare triangles. We would ultimately want to come down to a ratio of the 3 sides, x, y, z, where each of those values are the smallest possible integers. So we want to get it down to whole numbers, integers, but as small as we can, looking for common ratios. And so all 3 of these triangles have a 3, 4, 6 ratio. Okay, using the idea of similar triangles, we can actually determine heights of objects that are difficult to measure. The most common way that this is done is using what's called a shadow measurement. And the idea behind a shadow measurement is if your sun is up here shining down on everything, that it's going to cast a shadow with the same angle to the ground for every object. So since we assume that everything is standing at a right angle to the ground, and this angle over here is going to be the same for each object at the same time of day, then we know that these two triangles are going to be similar. In geometry, again, they'll refer to it as angle-angle similarity, meaning if 2 of the angles are the same, then all 3 of the angles from this figure to that figure will match, and that's how we know that the figures are going to be similar. So going through the information here, it says the totem pole's shadow is 45 feet long. So I know this part right here is 45 feet. And the 6-foot tall man, so that's his height, so this is 6 feet tall, has a shadow 3 feet long, so the shadow's 3 feet long. And our job is to find the height of the totem pole, which is this distance here. So to solve this, I'm going to use this idea of ratios again. I can either set it up as the height of the object to the shadow of the object. That's kind of like when we looked at the ratio of the 3 sides in any one of the triangles. So in that case, I would go x over 45 has to equal 6 over 3. Or I could do it from one figure to the next, where I would look at the totem pole versus the man. And so I could set that up and go x to 6 is equal to 45 to 3. Whatever you decide to do, you just need to make sure that you're consistent. So if we're going height to shadow, then we're going to go in one object, and then we're going to look at the other object. If we're comparing figure to figure, then we want to make sure that we're matching up sides. So these are the heights, and this right here is the shadows. In both cases, notice that when I go to solve the proportion by cross multiplying, I'm going to get 6 times 45 equals 3 times x. I get it here. I also get it over here. And so when I go to finish solving this, 6 times 45 is going to be 270 equals 3 times x, and dividing by 3 on both sides so that I can get a coefficient of 1 gets me 90. And so I find out that the totem pole is 90 feet tall. Now, going back to see if this makes sense, notice that the height of the man is actually twice his shadow. So the height of the totem pole should be twice its shadow, and that actually works. So I know that that's going to be good. This is the same kind of problem. I want you to pause and try the problem yourself. Make sure that you come up with a picture that you label. Then you set up your proportion and solve it to find the answer. Once you've solved it, then play the video for the results. Okay, I hope you tried this problem. I'm going to get rid of the things in front so that you can check. Here is my beautifully artistic picture of my forest ranger and his shadow, and my tree and its shadow. And I've got everything labeled, so we've got the ranger's height and his shadow length. and we've got the tree has an unknown height, but we know its shadow length. So as I go to write my proportion, I have this set up as height over shadow. So I'm looking at first the ranger, height over shadow, and then the tree, height over shadow. If you set it up instead as the ranger compared to the tree, and that would be fine as well, then one of your ratios is going to compare heights, 150 to X, and the other ratio is going to compare shadows, 45 to 195. Again, making sure that the ranger's measurements are on top and the tree is on bottom. Once you've got your proportions set up, you cross multiply and you solve, you should end up with the tree's height to be 650 centimeters. And since every 100 centimeters is a meter, we would change this into 6.5 meters, because when we talk about large objects, we want to use the most appropriate measurement units, which in this case would be meters. Okay, for this problem, we're trying to figure out the original price of a stereo. It says that it's advertised as 65% off, and what you paid, the sale price of it, is $136. Now, understand that when we have been setting up proportions or equations for this type of stuff before, if we set up the percent savings, which is 65% over 100, since this is the percent that you save compared to the whole or original price, then your dollars over here has to be dollars saved compared to the whole or original dollar amount. Now, since we don't know the dollars that we saved, and we don't know the dollars of the original amount, we've got two things in this proportion that are unknown. We're not going to be able to solve it. So instead, we're going to look at the dollars that we paid compared to the whole or the original amount, because we do know that we paid $136 compared to the unknown original amount. So the percent that we paid is the whole price minus the savings. And so the percent paid is 35%. If we set up this problem with 35% over 100 equals the amount that we paid compared to X, we'll be able to then solve this proportion to figure out the value of X, the original price of this item. So if we set up our proportion, again, I just set it up there, but we can see right here that same idea. And then we go through and we solve this proportion. You're going to find that your original item cost about $388.57. Now, we want to make sure that this makes sense. We're just going to do an estimate here. Since we're saving 65%, we're going to be paying less than half the price of this item. And half of this would be half of 300, and half of 80, and half of 8. So half the price of this item is $194. We should be paying less than that. And you can see that we paid $136. So this seems relatively reasonable if this is 50% of the price. So the assignment that you need to do here is on pages 124 and 125. Also a couple problems on page 143. Remember that if you're having problems with any of this, to come in and ask for some extra help. Good luck.